Okay, so let me get my cursor going. All right, so let's draw some axes here for this problem. Okay, so in blue, I'm going to draw the plane. So the plane has an airspeed of 160 kilometers per hour, and it's in the direction of 80 degrees. So that means from due north, leaning 80 degrees towards the east because you go counterclockwise. That means this guy, ooh, that's terrible. This guy here, close enough. That's the plane vector. But then to represent the plane vector using this formula, the vector theta that's in this formula must come from the positive x-axis, so this angle here. So that'd be 10 degrees. So you would say the plane's magnitude, you're told, is 160, and the angle is 10 degrees. So that's the plane's vector. Okay. Now the wind is coming from 350. I should not have drawn that axis still big. That's okay. I'll draw another set. So I'll do the wind down here. Okay. So the wind is coming from 350. I'll do that in purple. So again, from due north, rotating 350 is about right there, right? But if it's coming from that angle, then it's really pointing towards 180 minus that, which would be what, 170? Again, let me do that again. So that angle would be from due north, so it's really pointing towards 170. However, in that formula that I have up top, you have to be from the positive x-axis. So we're really looking for this angle theta here. That would be 10 past 270, which would make it 280. So the wind's vector would be, it's blowing at 25 kilometers per hour, cosine of 280 degrees, vector I plus sine of 280 degrees, vector J. Okay, so now what you do is just like what we did in class. You'd rewrite the plane by distributing the 160 through. You'd rewrite the wind by distributing the 25 through. And then all of this would be the coefficient of vector I. Oh, I accidentally left the I there. And all of this would be the coefficient of vector J. So you would call this A in your calculator if you wanted to. You'd call that B in the calculator. And then you're asked to find what will the plane's actual bearing be. Well, what I would figure out is I would figure out the decimal value of A and the decimal value of B, because this is too close for comfort. And what I mean by that is if A should be positive, right, because it's going to the right somewhere, but B could be positive or negative. We don't know how, my drawing's not to scale at all. So maybe the plane got pushed into a southeast instead of a northeast. So if you figure out the decimal for A and the decimal for B, and that will happen when you put these numbers in. So you'll say this plus this is A and this plus this is B. When you figure out your A and your B, that'll tell you what quadrant you're in. And then based on your quadrant, you could do like a tangent inverse to figure out, okay, because this would be, no, excuse me, that would be A, and this would be B. So you could use that guy to figure out either this angle here or this angle here. When you go to find your answer, though, remember it has to come from the positive x-axis because that's what the bearing is from the positive x-axis, just like the other two angles you're given. All right, I hope that helps.